Welcome to your Newton online class. In this video, I want to solve this particular question on the board, which is a topic in physics taken from moment of forces or a principle of equilibrium of forces. Now let's look at the question. A uniform meter rule of mass 90 grams is pivoted at the 40 cm mark. If the rule is in equilibrium with an unknown mass m placed at the 10 cm mark and a 72-gram mass at the 70 cm mark, determine m. So we are expecting to find the unknown mass m that keep the body in equilibrium when the other masses were suspended at other points. Now, before we venture into solution of this question, we should recall the principle of moment of forces. First of all, what is moment of force? It is the product of force and the perpendicular distance from each point of action or pivot. That is the turning effect of a force upon a point. Now, having known this, the principle of moment of forces to operate, that for a body to be in equilibrium, that the sum of clockwise moment of forces about the same point is equal to sum of anti-clockwise moment of forces about the same point for the body to be in a state of equilibrium. Having done this, let's venture into solution of this question. Now, we are told that it is a uniform meter rule. Therefore, being a meter rule, it simply means that the length of that ruler is what? 100 centimeter. Because 100 centimeter make 1 meter. Now we have let this be our meter rule. So let this represent our meter rule. So that here is 0 cm mark. Then here is 100 cm mark. Then from the information given, the mass of the meter rule is 90 grams. And the mass of the meter rule is expected to act toward the center of gravity of the meter rule. That is toward the center mark, which is 50 cm, because half of 100 is 50 cm, unless otherwise stated in the question. Now the mass of the rule is 90 grams, acting here, and the center here is 50 cm. So that's the secret there. Then we continue. And we are told that the meter rule is pivoted at 40 cm mark. That the pivot is at 40 cm mark, the turning point. Then we have the 40 cm mark somewhere here. Then here, 40 cm mark. That's the pivot. So it is pivoted at 40 cm mark. Let's call here P, the pivot P. Then we continue. If the rule is in equilibrium with an unknown mass M placed at 10 cm mark, there's an unknown mass placed at 10 cm mark somewhere here. So let's shift this one closer to this. You know, this is a sketch. Then 10 cm, let's here 10 cm. The unknown mass was suspended here. Let it be M, as given in the question. Unknown mass M was suspended here. Then, the question further tells us that 72-gram mass was suspended at the 70 cm mark. So be mindful not to misplace mass in the position of the mark. That is the scale, the calibrations of the meter rule. The one in cm is the calibration. The one in gram is the mass. If in Newton, it is the weight. So we have 70 grams placed at 70 centimeter. So let's here be our 70 cm. Let's here be our 70 cm. 72 grams. So this is a pictorial representation of the information given. Now let's go for further interpretation analysis to get the distance. Having known that moment of force is product of the force and perpendicular distance, but in this case we have masses here. So we work with the masses as in the place of the forces. Now let's look at the distance of these masses from the pivot P. Then the pivot will be P. Now distance of the mass M. We can label the masses to be M1, here M2, here M3. Then for guidance. Now, distance of this M1 from the pivot, from this pivot, is 40 minus 10, which is 30 cm. 30 cm. Then distance of the 90 gram mass from the pivot is 50 minus 40, which is 10 cm. Then now, distance of, we're not talking about distance, be mindful of here. Distance of the 72 gram mass from the pivot should be 70 minus 40, which will give us what? 30 cm. Not from here, but from the pivot. Then we can label the distances. Let's call here D1, call this particular one D2, and call this particular one from here to here D3. Then we progress. Now, the next thing is to take the moment of the forces, that the mass is acting as the forces about the point, the pivot P. Now, here is the what? Here is the anti-clockwise moment. Why all this, keeping this side in equilibrium, is the clockwise moment. So you see it has left and right, right? The pivot is the demarcation, the turning point. Now, taking moment, about P. We have that for the anti-clockwise moment, we have M1 times D1 equals, for the right hand side, we have two masses there, representing two forces acting on this. We have M2 times D2 plus M3 times D3. So this is the equation formed in line with this principle of moment. Then we proceed. Here we substitute. We don't have M1, we are looking for M1 times our D1 is 30 cm equals our M2 is 90 times our D2 is 10 cm plus our M3 is 72 times our D3 is 30. Then we continue. 30 times 10, we have 30m equals 90 times 10 is 900 plus 72 times 30. We have 3 times 2 is 6, 3 times 7 is 21. Then you put this 0 here, giving us 2160. Then we continue. 30m equals 900 plus 2160. 900 plus 2000 will give us 2900. Then plus 160 gives us 3060. 3060. Then we divide both sides by the coefficient of m. Have m equals 3060 over 30. 0 cancels 0. Then 3 divided 3 gives us 1. 3 divided 0 is 0. 3 into 6 is 2. Therefore, the unknown mass m we are looking for equals 102 grams. Remember the unit. Thank you. I believe you enjoyed this particular solution. Now, for more of these solutions in physics and mathematics, kindly visit my YouTube channel, like, subscribe, and share.